Hi guys, today's video is going to be on the topic of distance formula. So as the name suggests, we will be understanding how to calculate the distance between 2 points if their coordinates are given. So let us consider 2 points A x1 y1 and B x2 y2. Now the x coordinates are always called as abscissa and the y coordinates are known as ordinates. So since the abscissa of point A is x1, therefore its distance from the origin on the x-axis will be x1. Similarly, its distance from the origin on the y-axis will be y1. In the same way, we get the distance for point B as well. Now since the distance x2 is greater than x1, therefore length AC will be x2 minus x1. And similarly, distance y2 is greater than y1, so we will have the length of BC as y2 minus y1. Now if we look carefully, we'll notice that triangle ABC is a right angle triangle with AB as the longest side. So by Pythagoras theorem, we will have hypotenuse square is equal to the square of the sum of the other two sides. So we'll have AB square is equal to, if we put the coordinates of AC and BC, we'll get x2 minus x1 the whole square plus y2 minus y1 the whole square. So therefore distance AB is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is our distance formula. So even if we interchange the places of x1 and x2, the value of the formula will still remain the same. So if we put x1 instead of x2, so we'll have x1 minus x2 the whole square plus y1 minus y2 the whole square. So the answer will still remain the same because ultimately we are squaring each bracket. So you can try that out and see that you'll get the same value. Now let's look at our first question. So we need to find distance between 2 points 3, 6 and the other point 0, 2. So let's say that 3, 6 is equal to x1, y1 and 0, 2 is equal to x2, y2. So therefore by using the distance formula we'll get square root of 0 minus 3 the whole square plus 2 minus 6 the whole square. So that gives us square root of 25, which is 5 units. So the distance between these 2 points is 5 units. Next we have to find the distance between origin and a point minus 12, 5. Now we know that the coordinates of origin are always 0, 0. So let 0, 0 be x1, y1 and minus 12, 5 be x2, y2. So again by the distance formula we'll get square root of minus 12 minus 0 the whole square plus 5 minus 0 the whole square, which gives us square root of 169 and that is 13 units. The next question is a bit different. We have to find a point on the x-axis which is at a distance of 5 units from the point 6, minus 3. Now any point when it lies only on the x-axis, we always have its y-coordinate as 0. So we can say that let the point which lies on the x-axis be x, 0. So now our 2 points are x, 0 and 6, minus 3. So again by distance formula we'll have square root of x minus 6 the whole square plus 0 minus 3 the whole square. Now the distance already is given as 5. So if we equate the two things, we'll have 5 is equal to square root of x minus 6 the whole square plus 0 plus 3 the whole square. Now to solve this further, obviously we'll have to square both sides. So squaring both sides, we'll have 5 square is equal to x minus 6 the whole square plus 0 plus 3 the whole square. So that is 25 is equal to x square minus 12x plus 36 plus 9. So if we add and rearrange the terms, we get x square minus 12x plus 20 is equal to 0. So solving this equation by the method of factorization, we will have x is equal to 2 or x is equal to 10. So our required points will be 2, 0 or 10, 0. Now let's look at the next question. We have to find coordinates of point A which are at a distance of root 10 units from the point 4, 3. Now they have given us the relation between the ordinate and the abscissa. So again let's begin by saying that let point A be x, y. Since they have given the ordinate is twice the abscissa, therefore we have y is equal to 2x. Therefore the point becomes A x, 2x. Now they have already given us that the distance is root 10. So by the distance formula we will have root 10 is equal to root of x minus 4 the whole square plus 2x minus 3 the whole square. So instead of putting y, we will put the value of 2x as per the above condition. So we will have 10 is equal to x square minus 8x plus 16 plus 4x square minus 12x plus 9. So by solving it further, we will have x square minus 4x plus 3 is equal to 0. So by factorization, we will get x is equal to 3 or x is equal to 1. Therefore, the point will be a 3 comma. Now the value of y will be double of x. So points will be a 3 comma 6 or a 1 comma 2. Now in this question, we have to prove that the four vertices are the vertices of a rectangle. So let us first draw the quadrilateral and name its vertices. Now for PQRS to be a rectangle, opposite sides will have to be equal, which is a property of the rectangle. So therefore distance PQ should be equal to distance SR and distance PS has to be equal to distance QR. So by distance formula we will get distance PQ is equal to root 72 units and distance SR also will be root 72 units. Therefore distance PQ is equal to distance SR. So similarly you can calculate and find out that distance PS comes to be equal to distance QR and that value is root 18 units. Therefore we'll say that PQRS is a rectangle. Okay, so let's solve our last question. So we have coordinates of the center and another point through which the circle passes and we have to find the area of this circle. Now since the circle passes through the point minus 7 comma 2, so that will mean that this point will lie on the boundary of the circle. Hence distance between 5 comma 3 and minus 7 comma 2 will be equal to the radius of the circle. So again by using the distance formula we can have the radius is equal to square root of 5 minus minus 7 the whole square plus minus 3 minus 2 the whole square and that will give us 13 units. Now the formula for the area of the circle is pi into square of radius. So if you substitute the values, we'll have area is equal to 3.14 which is the value of pi into 13 square. So that gives us 530.66 square units. Okay guys, so hope you found this video helpful and do come back to check my upcoming videos as well. Until then, see you.